A scientific measurement is a measurement that is taken to concisely and clearly convey an observed value. Scientific measurements are often made in metric units. It is important to know that a measurement is a quantity given as a number, and a unit. Without unit, the measurement makes no sense. In scientific notation, a given number is written as the product of two numbers, a coefficient less than 10 but equal or greater than 1, and 10 raised to a power. The scientific notation is helpful in the determination of the number of significant figures. Significant figures are all the digits in a measurement that are known, plus a last digit that is estimated. Below some examples of how to write numbers using the scientific notation. Here are the rules to determine the number of significant figures in a measurement. Every non-zero digit in a reported measurement is significant. Zeros between non-zero digits are significant. Trailing zeros after a decimal point are significant. Trailing zeros, without decimal point, that are known measured values are significant. Leading zeros in front of non-zero digits are not significant. Zeros that act as placeholders to show the magnitude of a number are not significant. Example: 7,000 meters, measured in thousands of meters, has only one significant figure. Counted numbers that are exact are exactly defined quantities. These have an unlimited number of significant figures. Examples: there are 23 people in the classroom. This is a counted number. Or 60 minutes is equal to 1 hour. This is a defined quantity. Remember, a measurement is a quantity given as a number and a unit. Exact numbers, also called counting numbers, are quantities that are defined or obtained by counting, not estimated. Example: 1 hour is equal to 60 minutes, or 1 dozen is equal to 12 by definition. Exact numbers are not measurements. Let's count the number of coins shown here. We can count that there are exactly 7 quarters, so this is not an estimate, but an exact number. Measurements are always inexact, so there is always some estimating going on, and there is always an error associated with a measurement. When performing a measurement, they should be accurate and precise. But what does that mean? Accuracy is how close the measurement is to the accepted, or true, value. Precision is how close a series of measurements are to each other. In other words, accurate means correct, and precise means consistent or reproducible. Accepted values and experimental values often differ. In other words, there is always an error in the measurement. The accepted value is the correct, or true, value based on reliable references. The experimental value is the value measured in the lab, and the error is the difference between the experimental value and accepted value. The error can be used to calculate the relative error, expressed in percent. The percent error of a measurement is the absolute value of the error, divided by the accepted value, and then multiplied by 100%. How can we increase the precision of a measurement? Let's illustrate this with an example. Let's measure the length of the red rectangle with 3 different rulers. Each ruler has a different precision. The top ruler only shows the 10 centimeters division, so we can only give an estimate between 0 and 10 centimeters. A possible estimate is 7 centimeters. The middle ruler has centimeter divisions. We can determine that the length is between 6 and 7 centimeters, so a possible estimate is 6.4 centimeters. The bottom ruler has divisions in millimeters. The length of the rectangle is between 6.3 and 6.4 centimeters, with a possible estimate of 6.35 centimeters. Conclusion: the last digit is the estimated digit. The number of divisions determines how precise the ruler is. The standard of measurement used in science is the metric system, which is simple and easy to use. The International System of Units, also called SI units, is a revised version of the metric system. There are 7 SI base units, as shown in the table below. Metric units can be used with prefixes for convenience. In the table above, the most commonly prefixes are shown. Example: a human hair is about 0.00007 meters thick. A more convenient way to express the thickness by using a prefix is 70 micrometers. Size is an important property of matter. In SI, the basic unit of length is the meter. The space occupied by a sample of matter is called its volume. Length, width and height are expressed in meters. So, the unit for volume is derived from units of length, and is the cubic meter. A more convenient unit to use for volume is the liter, which is a non-SI unit, but a metric unit. Mass is the measure of quantity of matter. The SI unit for mass is the kilogram. Derived metric units of mass are shown in the table. It's important to note that mass and weight do not have the same meaning. Weight is a measure of force, it is the pull force on a given mass by gravity. Temperature is the measure of how hot or cold an object is. The SI unit of temperature is Kelvin, symbol capital letter K. There are different temperature scales. The Celsius scale has 100 divisions, between the freezing point of water, 0 degrees, and boiling point of water, 100 degrees. The Kelvin scale sets absolute zero as the 0 point of the scale. The freezing point of water is 273.15 Kelvin, and the boiling point of water is 373.15 Kelvin. The formulas below show how to convert degrees Celsius to Kelvin and vice versa. Density is an important intensive property that depends on the composition of a substance, not on the size of the sample. Density is defined as the ratio of the mass to the volume of an object. Density will tell you if an object will float on water or not. Below, densities of some common liquids and gases are shown. A conversion factor is a number used to change one set of units to another, by multiplying or dividing. A conversion factor can be defined as the ratio of equivalent measurements. A ratio of equivalent measurements is equal to 1, so the size of the quantity does not change when multiplying or dividing by the conversion factor. Dimensional analysis is a method of problem solving by using the units, or dimensions of measurements. Let's do an exercise with conversion factors. If the density of water is equal to 1 gram per cc, what is the density in kilogram per cubic meter? Use conversion factors for mass and volume. The solution is given below, and the answer is 1000 kilograms per cubic meter. Let's do a quiz about significant figures. Similar exercises can be found if you use the link shown above. Now let's pause the video and try to find the significant figures for the following numbers. Here are the answers for the quiz on significant figures. Pause the video to verify your answers.